right. At Kytos, we want to become the microbiome management service for horticulture. And why do we want to focus on that specifically? As you know, there are a lot of losses that can be attributed to plant disease. And it's our belief to do not only focus on pathogens, but really look at the whole microbiome and preserve a healthy, resilient microbiome to reduce disease, chemical use, and promote plant growth in the end. I don't have to tell you that's a significant market opportunity, especially here in Benelux, where we have a lot of high-tech greenhouses. And that's also where we focus on. The greenhouse is a very complex environment with a huge microbiome, and it's really the unseen majority in that greenhouse. We have it in the irrigation water, we have it in the substrate, we have it in the drain. And our job is to go from that greenhouse and really bring it to the palm of the farmer, the palm of the hand of the farmer or the crop advisor, to really be able to look at that microbiome and make actionable decisions on that. So what do we offer specifically? We can allow the farmer insights into the microbiome health, the global microbiome health, to modulate that resilience, but we can also show how the microbes are active, even in the substrate, even in the part that is not that well visible. And finally, we are developing using AI, specific recommendation engines to show how you can do precise dosing of sanitizers and biostimulants in the greenhouse. So why Kytos? Why are we different? We are actually not using DNA-based technologies. We're not plating. We're using flow cytometry. And that's the core of what we do. Every single biological cell, be it an algae, be it a water fungus, be it a bacteria, will pass by a laser and we will generate a high throughput and very scalable single-cell microbiome data that we can use as an input for our machine learning models. And that's our power, together, of course, with our team, that we can translate that multivariate data set into actionable insights. So we started in 2021 in Belgium. We have had a nice and steady growth. We also started labs in Vietnam and Thailand. And this moment, we have a huge reference database of microbiomes, partially in aquaculture, but also already over 20,000 microbiomes profiled in horticulture and all kinds of crops, from the water, from the substrate, even from the sediment and from air. Where do we want to go? We want to expand our partner and distributor network, and we want to further develop this AI platform. We really want to be able to give precision farming advice based upon the microbiome. And of course, at our existing labs, we want to expand our horticulture growth. So we're looking for product suppliers. We're not the ones making the sanitizers. We're not the ones making the biostimulants, but product suppliers that are interested in coupling this with our AI model, and investors to grow our technical sales and our key account management. So thank you very much, and I'm open to all the questions you may have.
Maybe one question from my side, Frederik Maarten. So can you name an example of a use case that you have with a tomato grower or one of your other customers, where you make a direct impact on their daily business? Yeah.
Thank you, Lutz. So essentially, when we have a subscription with the farmer, they do get data before they even see that their plant is getting sick. So we had a very nice use case with a tomato grower where there was crazy roots in the substrate. The plants were not really showing.
Sorry, crazy roots?
Agrobacterium infection.
Okay.
Sorry, not rhizogenic agrobacteria infection. And we were able a month in advance to already see that something was going on. And that was, and at that case, a technical issue because one of the tap sections was not properly opened. But we were able to identify that, and by showing that in time, they were able to recover part of the crop. Yeah.
Yeah, so I think this question already partly answers my question, but I was wondering, how do you correlate your data sets of flow cytometry data to function and specifically soil health, I guess?
Well, yeah, we don't look in soil most of the time, it's in substrate, but the question still stands. So there's multiple layers to that answer. But the first one is we actually benchmark it with sequencing data that we actually use as an additional layer to contextualize our data. So we are able to very nicely correlate this phenotypic fingerprint that we have with actual genotypic data for example, of bacteria, but also for water fungi like Phytophthora, Pythium, Fusarium now even. So we're really making great strides in that. So we generate this coupling, and then the second level of data is, of course, yield data, which ultimately is what the farmer is most interested in. And there we're working together with larger corporations of, for example, tomato growers to integrate that data and couple it to our models. Yeah.
All right. One more question. Yes, there
one over
or
there.
two. Podriak?
Ooh, nice.
Thanks. Sounds really interesting. Why are you just working in greenhouses? I can see this also being very useful outside in the field, also for disease monitoring, things like that.
Excellent question. Right now, we also need to focus. We've heard it before. We need to focus. We're a small team, but also in the greenhouse, we feel there's more knobs that we can turn. The systems are more closed, and we can actually have a little bit better control over how we mitigate certain diseases in the greenhouse. Yeah. It's a question of focus, but also a question of being able to have high-tech buttons to turn. Yeah.
One more question here. Yeah.
Okay.
We know that microbiomes can vary a lot. Are you able to say how a good microbiome has to look like?
Thank you for that question. That's actually what we started with. So our general microbiome monitoring program does require some backend. And luckily by now we have over 20,000 profiled microbiomes in different crops, mostly tomato, bell pepper, and cucumber right now. But we are able to see the shifts. So we base ourselves on microbial ecology theory. We actually come from a microbial ecology lab to really look at resilience. We look at microbial diversity, and we try to, from the microbiome itself, predict the risk of potential disease outgrowth and the resilience against infection. But also how beneficial organisms would be in there as well. And so that's why we want to do this whole holistic view of the microbiome.
Thank you so much. Let's give a hand for Frederik Maarten.